Hi, welcome back. In this video, we are going to show how the heap works when we are adding a new number to it and how it can find the smallest value to put it at the root. So just imagine that this is our heap representation 1, 1, 2, 3, 5, 9, and 4. So we are having 1, 1, 2, 3, 5, 9, and 4. This is our tree. Okay. Then we would like to add one element and we want to add number 0 as the element. So we're going to use the heap push function and it is going to basically insert 0 at the next available position, which is the end of the heap. Okay. The end of the heap is here. So it is going to add it here. But what we see in the output is this one. For example, is this one. Sorry, is this one. Okay, because the number 0 is the smallest element, it is going to be at the root. And when we print the heap after insertion a small number like 0, we see that the heap looks like this. For example, it is having 0, 1, 2, 1, 5, 9, 4, and then 3. Okay, but how do we get to this output? This is the final heap that we see when an insertion of 0 is done, because 0 is smaller than any other element in this heap. So this is our heap. We see that if we add 0, 0 is the smallest element here. And at the end, we are going to see this one, okay, which is like this. But there are some steps that the compiler goes through to get to this final heap that show us in the end, in the output. In order to understand, so here was my original heap. We added one number, which is 0. So 0 is smaller than the smallest element in our heap. So we are going to insert it, and we are going to insert it here at the end of the heap initially. Then we are going to have a comparison. So the comparison would be like this. So here is the list representation after adding number 0. So 0 is here. But 0 is going to be compared here, okay? So 0 is smaller than its parent, okay? You see it here. So 0 is smaller than its parent. So the parent is 3 and 0 is the child. So because it's smaller, we are going to swap their position, okay? So we are going to swap their position. So 3 is now down and 0 is a bit one stage higher. Then we are going to compare this 0 with this one. Okay, so child is smaller than its parent. So we are going to swap them as well. So here would be the output. We are going to have 0 here and we are going to have 1 here. Why? Because the child is being compared with its parent, and when it is compared with its parent, it is smaller, so we are going to swap their position. So when we are swapping their position, we get to this tree, and now when we are having number 0 here, and this number 0 is lower again than its parent, which is number 1. So there we are going to swap their position again, and finally we are going to reach to this final heap that we see in the output, because now the smallest number is at the root. So this is the numeric representation of our heap. So this is in the end the heap that we are going to get, but there are steps that it goes through to find the smallest element in our heap to put it and move it at the root node 0. So it was an interesting example to see what the procedure is for the compiler to move a small element to the node 0, to the root node. Thank you for watching.